Hello everyone, welcome back to the course. In the previous video, we have discussed about the signals and their representation. In this video, I am going to introduce you to the most fundamental concept, that is signal amplification, which is employed in almost every electronic system. Particularly in this video, we will discuss only about the external characteristics of an amplifier. The internal characteristics we will discuss in the further upcoming videos. So in the last video we have seen that a physical signal can be converted into some electrical form with the use of a transducer. But the signal which is provided by this device is very weak, that is in some microvolts or millivolts, which is not suitable for the processing. Therefore, there is a need for the signal amplification, and the signal amplification is done by the signal amplifier. So, signal amplifier is a circuit that increases the amplitude of an incoming voltage signal or current signal. The output signal of an amplifier is the exact copy of the input signal with the larger magnitude. A signal amplifier is represented by the symbol, which is represented by the figure 1. Here, this is the input terminal where we apply the input signal which is to be amplified, and this is the output terminal that provide output, and this is the ground terminal for the stabilization of the circuit. Input output relation of the amplifier is expressed by this expression, where VIT is the input signal, A is the amplifier's gain, and V naught T is the output signal. And the transfer characteristics of the amplifier is represented by this curve, where y-axis represent the output voltage and x-axis represent the input voltage, and the slope of this curve tells about the gain of the amplifier. As we have used voltage here as a signal, so this is called a voltage amplifier. There is one more type of amplifier that is known as power amplifier, which provide an adequate amount of voltage gain and enough amount of current, and also it takes very small power from the signal source and deliver a large amount of power at the load. So here are some gain parameters which are frequently used to describe the behavior of an amplifier. So these are voltage gain, power gain and current gain, which are actually the ratios of the output signal to the input signal, and they can also be represented by the decibel forms. The decibel values is just a logarithmic way to express any signal ratio. It is required when the value of the gain becomes so large. Now we know that in the amplifier, the power delivered to the load is greater than the power drawn from the signal source. How is this possible? This is possible because an amplifier requires a DC power supply for their operation, as this provides the extra power delivered to the load as well as the power dissipated by the internal circuit. Actually, an amplifier needs two power supply. One is positive and another is negative, and that is connected to the circuit as this is the amplifier. This is signal source. This is the ground terminal. This is the load resistor. Which is connected to the output terminal, and this is the positive power supply. And this is the negative power supply. Okay, if we assume that the current drawn from this supply is ICC and current drawn from this supply is IEE, then we can write an expression for the power delivered to the amplifier, which is delivered power is equals to VCC, ICC plus VEE, IEE. And also we can write the power balance equation for the amplifier as the delivered power, the input signal source power equals to the power delivered to the load and power dissipated. Okay, so and also we can define one performance parameter, that is power efficiency, which is equals to the load power divided by the input delivered power into 100. One more thing, that we know that the output signal of an amplifier has a larger magnitude than the input, but there is a limit for an output signal that it cannot be exceed power beyond the level of power supply. So there is a range for the input signal Vs, so that the output will not get clipped off. So this is output signal by the gain. Okay, so this is the range for this input signal, so that we get full swing output signal. Let's have a look on the types of the amplifier, which can be classified based upon the different characteristics. So there are many types of amplifier based upon different characteristics such as signal types, types of interstage coupling, frequency range, and the output characteristics. So based upon the types of input and output signal, an amplifier can be classified as the voltage amplifier, current amplifier, transconductance amplifier, and transresistance amplifier. The voltage amplifier gives the output voltage signal in response to the input voltage signal. Similarly, the current amplifier provides an output current signal in response to the input current signal. The transconductance amplifier gives the output current in response to the input voltage, and transresistance amplifier gives the output voltage in response to the input current signal. Based upon the output characteristics, an amplifier can be a linear or a nonlinear amplifier. The linear amplifier is the amplifier that produces output signal without the introduction of any type of distortion, whereas nonlinear amplifier introduce some distortion in the output signal. Audio amplifier is a type of power amplifier. For example, it is used in the home stereo system for running the loudspeaker. Next is operational amplifier that performs various mathematical operation like addition, subtraction, multiplication, division, etc. Next is radio amplifier that amplifies the signal in the radio frequency range. Next is servo amplifier. This is a kind of amplifier which uses some feedback loop to control the output at the desired level. Next is based upon the types of coupling methods. An amplifier can be categorized as RC coupled amplifier, LC coupled amplifier, transformer coupled amplifier, and direct coupled amplifier. The RC coupled amplifier uses a network of resistors and capacitors to amplify any signal. Actually, this network provides the phase shift in the amplifier. Transformer coupled amplifier, which use transformer to match the impedance of the output side and the input side. The direct coupled amplifier directly connect the two stages of the amplifier in any electronic system. On the basis of frequency range, an amplifier can be categorized as DC amplifier audio frequency amplifier, video amplifier, and ultra frequency amplifier. A DC amplifier amplifies the signal with the zero frequency. Next is audio frequency amplifier that amplifies the signal in the range of audio frequency, that is from 20 to 20 kilohertz. Next is video amplifier that amplifies the signals up to few hundreds of megahertz. And the ultra frequency amplifier that amplifies the signal up to few gigahertz. Okay, so that's all for this video. In the next video, we discuss some circuit models of the amplifier that we have discussed today. Okay, so thank you.